Cool, we're recording. All right, let me begin sharing my screen. Okay, this is all right then. This is the right PowerPoint. Cool. Yeah, for this session, again, it's been advertised as natural language processing. Oh, we have a chat. Yeah, feel free to turn your camera off. That's totally fine. So this session will be kind of going over basics of natural language processing, which to some extent is definitely too big of a lecture to really cover all the various methods in NLP analysis. And so I think this lecture will be mostly thinking about some of these methods in terms of how useful they could be to sociologists and for social theory, because that's what most of us are using these methods for. And I'll give you some, I'll share some code and how of using some of these methods and how to apply them to research questions and data that sociologists might care about, but also some limitations in that demonstrate like using these methods themselves aren't necessarily the end goal of analysis. They're not going to totally explain truth to you, and that you as the researcher still need to be heavily involved in the process and kind of use your own domain knowledge of your own sociological insights of concepts to make use of these tools. But still, I think that these tools still can be very useful in different ways, and maybe some of what we'll be going over this lecture will highlight some ideas for you. So I won't be going too much into this, but I do want to give a little bit of a cautionary note when using these methods for the first time for social theory, in that when using text analysis to analyze social theory, I think we could easily fall prey to assuming that computational tools in and themselves would kind of revolutionize analysis. To some extent, they are very powerful tools to process large amounts of text data in ways that you as a human being would not be able to do. But as social scientists, our end goal is to think about how to use these tools to operationalize and contribute to operationalize underlying sociological concepts, which I think is the key challenge of using these methods, especially for beginners and novices. I kind of consider myself in that area as well, because I'm still working through some of these methods, but I'm able to share with you some challenges that I've encountered, and hopefully these will be lessons to some of you when you're choosing to use these methods in the future. And there are a couple ways to think about this. One, I think, particularly with the data sources, a lot of people are interested in, like social media data. We need to think about how the data was collected and to what extent the data is representative of our scope conditions, because a lot of the time, the data that we use, if you look at Twitter or Reddit or other social media platforms, they are collected. They don't necessarily fulfill like some key goals that we want to achieve with sociological theory, such as is this data representative of the population in general? For instance, is Twitter data representative of the U.S. population? The answer is no, definitely not. We have surveys that demonstrate that not everyone's on Twitter, but I do want you to keep this in mind when you're using these methods, to pay attention to how the text data itself is collected, and what are some limits about what you can say and what you can say and what you can't say using that data. And another thing to consider as I got get at before, as when we're using these tools, we should think of them as tools that help inform us about what's going on in the data and give us insights into data. So they are, I think, honestly, the beginning. They serve on like the beginning front end of analysis, um, rather than the end goal of analysis. They're not. They're generally not just the outcome, like the outputs that you get from a lot of computational tools are. You kind of have to validate them to make sure that they're actually measuring the concept you want to measure. And so you realize that there's a lot of steps that I've noticed when I began using analyzing text data. That there's definitely a lot of steps to pre-process text data, and this is particularly important because what you put into a model uh, shapes has a great impact of what you get out of it, in a way. In that if you put in kind of garbage data into your model, you won't really be getting results that are actually operationalizing sociological concepts that we care about. And this other knowledge that when we're using these tools, I want to be clear that to have that these tools we should use these tools in order to uh, we should leverage these tools to the best of our abilities to guide our research question, not just lead us. Well, we should use these tools to answer the correct research question rather than using these tools to kind of totally guide our analysis. And that you should rely on your domain knowledge as well when you're looking at these data, and rely on existing sociological concepts as well. Again, just goes on to this goes what I'm talking about earlier. We should, whenever you get any outputs, you should kind of understand where it's coming from, where these outputs are coming from, and honestly validate these results, as I'll demonstrate later, and not really rely on the outputs as is, because I think you'll run into a lot of difficulties into trying to operationalize these concepts into sociological theories, which is a lot more difficult to do. Okay, so putting that on the shelf, putting that aside, what are some examples of, you might be asking me, because you came to this lecture, what are some examples of methods of natural language processing? Or rather, what is natural language processing? Well, NLP, or natural language processing, I think it's just a variety set of slew of tools that, a slew of tools that are developed in computer science and computational linguistics that are used to analyze text data. That's kind of simple as it is in a way, but it's also very broad. And so there's a lot of different ways to approach NLP analysis and NLP methods. And this lecture, I'll only share with you a couple of them. So a couple of key concepts that I want you to learn about before we really jump into the coding is this notion of quote unquote bags of words approach to text analysis. Meaning that, and this concept is going to guide what a lot of what we'll be doing and what a lot of the code I'll be sharing to you soon enough. And what this means is that it's a bag of words approach. You can think about it. When you're analyzing text data, we as human beings read text through sentences. So we rely heavily on context to understand specific words. Kind of bag of words throws all that out the window and literally tokenizes text into specific words, sometimes multiple words at a time. And so you can imagine, if you look at this sentence, it's a simplification of data into single word segments, disregarding grammar and word order. What a bag of words approach does, it kind of takes this whole sentence or this whole phrase and splits it into specific words that you put in that you analyze on their own. So basically, you're analyzing text based upon the specific words involved. Now, because of this, this throws away word order, this throws away grammar, and this throws away context. But this is one way to simplify. This is one sort of slew of NLP methods that I think is very frequently used in, that I will frequently use in this lecture. There are other ways of going about this, like there are algorithms out there that are probably more advanced than what I'm used to and beyond my knowledge, that try and incorporate context into understanding specific meanings of text. So again, know that this carries a lot of assumptions that probably a lot of qualitative researchers will totally take issue with, and I think that's definitely a concern that we as social scientists should consider as well, like the various assumptions that we are using. But still, I would argue that even simplifying this data, it still can be useful for analysis. So I'll demonstrate a couple of methods below. So there's one slew of methods that I like to think of through that I would say are dictionary approach methods, which basically employ a Boolean approach in which, I'll give you a couple of examples, sentiment analysis or building your own dictionary of words. And basically this is literally this literally uses a dictionary that is another data set that has a word and associated meaning attached to a word. That might be where we might be able to infer what a text is about based upon what words are in the text itself. Sentiment analysis is one example of a dictionary-based approach. Another approach is also creating your own dictionary too. What dictionary-based approaches ask is literally, does a word that you think matters, let's say if you're analyzing, let's say that you're analyzing positive sentiment in, a news articles about mental health. What a dictionary approach would do is distill what people are saying or the text itself into words, and then from those words you will give a number or some sort of categorization of positivity, negativity, or other characteristic that basically generates a statistic in that if this word is located in the text itself, that is indicative of some sort of positive sentiment or not. And I'll give you some examples later on. So if it doesn't make sense to you right away, hopefully the examples will make sense to you. Another slew of methods that we'll go over today are known as unsupervised machine learning models. Now, machine learning models are it's a fancy way of saying what I honestly think are various algorithms that we can use to analyze data just generally. And there are two distinctions of unsupervised and supervised that you'll come across in the scholarship. Unsupervised models basically employ an algorithm that doesn't have any priors or pre-coded notions, but you apply this algorithm to some sort of text data or to some sort of data set that, where you're trying to discover new insights and new findings. So basically, I think unsupervised machine learning approaches are kind of akin to grounded theory approaches to analysis if you're used to qualitative analysis. So we're not starting with any pre-existing theories or any specific priors outside of what the model specifies, or we're just applying that model to some sort of text data. And name entity recognition and topic modeling are examples of that. And finally, the slew of yeah.
Just before you move on, could you maybe clarify a little bit the distinction between the bag of words and dictionary-based approaches?
Yeah. I think a bags of words approaches Well, a dictionary-based approach relies on a bags of words approach. And so a bags of words approach, you could correct me if I'm overlooking something, Scott, but I think a bags of words approach is a general framework that's used to analyze text data, in that we distill meaning into specific words, kind of disregarding context and word order. So dictionary-based approaches kind of build off that concept.
Yep. Yeah, I think that's yeah, I just wanted to clarify. So bag of words is just a general strategy of taking a text string and then counting each word individually. And so that can be implemented in a dictionary approach or another way. So yeah, thank you for clarifying.
Cool. Thanks, Scott. And this other approach called supervised machine learning models, which we won't be getting into in this lecture or in this workshop, but maybe we could go into it in another workshop. Who knows? A supervised machine learning model is again a variety of different models, but the key description here is that in these models you specify specific priors, which can be pre-coded concepts in the data, or a lot of you, in order to classify new data or to test theories. And to some extent, how I like to think about it is what a lot of us have already done, which is basic regression, like for instance, logistic regression. I think correct me if I'm wrong, but I think it is an example of a supervised machine learning model and how it estimates the coefficients from some sort of estimator. And that we specify, with any regression model, we specify our priors, we specify a dependent variable and we specify independent variables. And then we run the regression. That concept is kind of similar to how the logic of a supervised machine learning model works. And you could use this in a regression, but you could also use this, I've seen, in like classification algorithms. Let's say you want to apply a machine learning model to a new body of text. That is what people are talking about here. When people talk about they have a training set and like a training set and another set of data or a testing set of data. This is where supervised machine learning models are taking. They're using supervised machine learning models in that case. Okay. And so this one last slide before you jump into the actual text itself. What we'll be working with here is code in R, and I posted up. In the code I will use in this workshop on my GitHub page that you can encounter. The data are also on the GitHub page, but we'll be using R specifically in order to conduct some text analysis. And so some basic terminology is in order in terms of the workflow of what we'll be doing. So we're assuming right now that we have text data already that are relatively clean, that we can import from a CSV file or from any sort of JSON file into our data set. And from there, we'll be tokenizing and turning this text data, applying a bag of words approach to turn it into tidy text data. And you'll see what that actually looks like. And from there, I think is where more of the interesting things that we'll be doing here is we'll be counting data, we'll be applying dictionary-based approaches, and we'll be applying some unsupervised machine learning models, specifically named entity recognition and topic modeling to these data. Okay. So I will quit this workflow and let's jump to it. All right. Does everyone see the my RStudio open right now?
Yeah.
Cool, thank you. Okay. So there are a couple of packages here in order. I won't spend time going over all of them, but suffice to say, tidyverse is the main key package that we'll be using throughout this workshop. Specifically, tidyverse contains all the elements, all the all the tools in order to turn text data into tidy text data. And in terms of what the data that we'll be using as an example, which might be interesting to you, in this workshop, we're going to be using, can you post your GitHub again? Sorry. Yeah, I could do that. Let's see. Or rather, would someone else be able to do that? Yeah, thank you. Thanks, Vitali. That's where the data is located. So you could take a look at it on your own time as well. So we'll be using data that I've collected a long time ago, which is a random sample of newspaper articles covering George Floyd's death. 5,000 articles between May and July 2020. It contains his name and also, I mean, it's basically media mentions of George Floyd. What is the media talking about? We'll be exploring, exploring these data using these methods below. And so what I've done, so as you can see, these data are located into these CSV files. A bit of a note on how I like to manage text data. I think this is the case. This will be different if you work with like terabytes of data, but since I'm not working with terabytes of data, this will be fine. And that I like to keep text data and metadata separate into separate files connected to each other with a common ID. For instance, I have two data sets here. One is the full text file, and one is the data with metadata. Well, the data, yeah. And if we take a look at the data itself, the data set that contains the metadata, we could see like each row would be an article that has, it's a newspaper. These are its authors. You can see the publication title, the date in which it was published, title, document type, all of their features as well. And in terms of full text data, you can see it's basically consists of two rows. One is literally the full text data itself. The other would be an ID that uniquely identifies each data set. So in this way, I could easily join the metadata and the full text data back and forth whenever I need to. So in terms of pre-processing the text data, we're going to import this library called tidy text, and then we're going to do something called unnesting the tokens. In that, this is literally the function that we're using to turn this text data, Floyd full text, all of this into tokens, into applying a bags of words approach to this data. Let's run this. Okay, it'll take a while. Okay, we've stored this output into Floyd words variable. Now let's take a look at the Floyd words variable. Okay, what does this contain? All right, so we're seeing here that, this might not be surprising to you, but the top most common words in all these 5,000 articles are, the, to, and, of, a, in, that. You see policed, but to some extent, this makes sense because these are very common words we use in the English language. So one of the things that we use to pre-process this data is we use a stop words dictionary to remove these common words that might not be meaningful to us in our bags of words approach. We could do this by just, and tidy text already has inbuilt dictionaries of stop words that we could use. And you can see here, they have a list of words that you could look accordingly. And then you can create your own stop words as well, which I've previously done. Let's see, which contain a lot of words that, a lot of issues of text, as you can see that the text itself has some problems in that it has some leftover characters that aren't necessarily words that are still contained in it. That makes it not totally clean data, but we'll just be working with that. And so once we create our stop words dictionary, you can see here, we could use something called an anti-join. We could use something called an anti-join to remove all the words in the data that are commonly used in our stop words dictionary. Running this, we've removed a lot of words already, and then we could actually, let's see here. We could look at the most common 20 words in the 5,000 articles that we're looking at. And so we're getting at here, something that's makes a lot more sense. And that we see police, we see people, Black Americans, for the most part, George Floyd, officers, city protest, officers, law, time, department, community, Trump, justice, and president. Okay. And I think the value of, I think, it might be tough to really get at, okay, these are most common words, these are obvious, but what can you actually do with the data now? And I think what a bags of words approach does, it allows us to use these word frequencies and be able to compare frequency of words across, other variables that we might care about. For instance, we could combine this with other metadata, like, let's see. We could combine Floyd words, which itself, as you can see, has around 2.2 million rows. And let's see, each word is a document, the actual document itself associated with the word that's in the document. And so we could combine other metadata. For instance, I want to look at, I want to combine the census, the census region of where the article was published. Maybe we could find something interesting if we compare top words of newspaper articles in each census region in the United States. So I'm just gonna run that. And in the Northeast, we see these sort of words, which are very similar to what we looked at previously. Maybe in the Midwest, we might see words that are more associated with a specific region, like Minneapolis, city, community, other sort of words. In the South, when we see newspapers in the South kind of report it in this specific way, and in the West, another specific way. So as you can see, what we're doing here is relying on the frequency. We're using the frequency of words as just one measurement of the data, and kind of applying other data as well to kind of assess what the data are about. In this case, we're looking at the most common words by census region. And there are other sort of questions that there are other sort of ways you could go about this as well in terms of word frequency. Okay, now we're going to move on.
Just to pop in, Todd, real quick, because I think this is a good place to insert. I think the way, when you see this data actually laid out, it really clarifies some of the weaknesses and the assumptions that go into the word of bags approach, because that use of stop words that you're doing, Todd, and we're getting to this dictionary method next, so we'll see that the stop words just fall out. It's really a data reduction strategy. And that means that we're losing all that information associated with context, and we're more or less acting like a Google search did in the 1990s. We're just looking for those key phrase matches. So we're losing a lot of information. But one of the interesting things is a lot of computer science has shown that these types of keyword matches actually get us really far. And we can get a lot of good information out of the bag of words approach. So we still get noisy measurements, and we often lose something. We get more measurement error when we use these bags of words approaches. But when it comes to things like evaluating the average sentiment of a text, or picking out key themes, or picking out key frames, then these keyword matches can actually go pretty far. So it's one of those things, I think, as sociologists, we see like these words getting pulled out of context and we're like, what is happening? We're losing the meaning. And to some extent, that's true. But we actually still get a lot of traction and a lot of distance, even out of these more rudimentary approaches, which I think is something that's really worth emphasizing.
Yeah. Thanks, Scott. Yeah, and this, kind of leads into what we'll be moving into our dictionary approaches that you kind of mentioned already, in which we're already going to apply. I've just, done some very cursory readings through the text, and I've identified a couple of words that I think might be, it's a stretch, but I'm just going to name it into a variable called the crime frame. Words like riot, lawlessness, damage, smashed, graffiti, burn, burglary, or looting. I kind of use this as one way to identify and use this basically as keywords to search the data itself. So we're going back to the Floyd full text data here, and all we're literally doing is searching through the text itself to identify the prevalence of these words, or on a more sociological conceptual level, the presence of these frames in some articles over others. So run this, and this is something that is very simple to do, and I think that's one of the key strengths of this approach. Even though, as Scott was mentioned, we're losing out a lot of data, and there might be some debate over whether or not these words actually capture the frame that you're getting at here. And so once we, so what we did here is we created a new column. Oh, whoops. We just created a new column, 1 and 0 column. Does this document contain crime or not? Or one of these words or not, which is very simple to do. As you can see, that occurred really, really quickly. And then from there, we could do further analysis of, you might be able to want to compare words located in, articles that didn't seem to have these words versus ones that did seem to have these words. And if we look at one specific example of an article, let's look at here. I chose this article, the first one basically that had one of these words associated with it. Let's see, America's biggest week of rebellion and social unrest may have sparked an agonizing to watch police custody video. You can see there's a lot of this article is talking about a lot of other things as well. But it seems to be, there might be some words, well, I know that literally the presence of some of these words in this document. Okay. So that's one approach, you create your own dictionary to apply to this bags of words, this tidy text format. Another is a sentiment analysis, which is already, you're creating another dictionary, or rather, there's actually a lot of pre-existing dictionaries out there, more than these 3 that I've listed before, in which people have constructed these dictionaries to get at specific sentiments like positive, negative emotions, or other emotions as well that each word might be associated with. And we'll get at this soon, but you're gonna have to be careful about what dictionary you use and how the researcher created that dictionary, and for what purpose as well. Because sometimes some of these dictionaries might not always be able to apply well to all types of text data. For instance, you might create a dictionary that you might apply to Reddit forums, for instance, might be very different from, you might get different results in terms of sentiments if you were to apply the same sentiment dictionary to news articles as we're doing here, because text data are very different from each other. And so just 3 examples of dictionary that are just right out of tidy text are, I don't know, AFIN being an NRC. Each of them have authors associated with how they created the dictionary. Well, we could take a look at each of these dictionaries themselves. So it looks like AFIN has a negative to positive score that they associate some sort of value from -5 to 5 to a word. So abandon has, according to this dictionary, is set at a negative value of 2. So it has a negative value of 2. Let's look at Bing. Bing itself, let's actually look at table Bing sentiment. So Bing itself divides words into negative and positive of just a binary measurements. So let's see, sentiment. And NRC, it looks like the authors and that who created this dictionary kind of associated words with different emotions. So it's like kind of a categorical measurement of sentiment. If you pay close attention to the actual dictionary, you notice that some words have multiple, are grouped into multiple categories as well. So we want to pay attention to that as well. So it's not as simple as one word belonging into one category, but words can belong into multiple categories of emotions according to this dictionary. Again, I'm not saying that any one dictionary is correct. I think you as a researcher need to decide which dictionary is most pertinent to the data set you're using and the research question you want to answer. So let's do this, quick exercise of applying these dictionary to our existing data. So let's apply the NRC sentiment data dictionary to George Floyd's to our data set already. Let's look at the top 20 words that are associated with the top 20 words in our data set. So we see here, I think you might already see a problem with this using this dictionary itself, because we're starting to see words that might not actually capture the meaning that we would think intuitively, knowing our knowledge of what this data is about. So the words police are kind of associated with like fear, positive, and trust, but also the word black is associated with negativity and sadness as well. This might make sense in other contexts, but in our context of looking at Black Lives Matter, this doesn't really work well, I think. And if you go down to the word white, you see white is associated with the words with the sentiments anticipation, joy, positive, trust. So even more so, as race scholars would probably be up in arms about, okay, this sentiment dictionary is totally useless to analyzing the data that we have here. And this goes to show why you should always validate your findings as well. And then we can apply other dictionaries as well to this approach, in that, okay, let's apply the AFIN dictionary to our data. We also see a couple of problems as well if you look at below, in that protesters are and racism are associated with negative sentiments, and this goes alongside with death and violence. And so it's difficult to with our data that we currently have, it's difficult to actually understand what does positivity and negativity actually mean. So in this case, sentiment analysis might not be useful, at least in order to provide like an overview of these data. Although, you might come up with ways in which this could be useful. And then from here, another useful thing is we could actually then be able to aggregate these findings and calculate the sentiment value of each document. So, in these first few lines of code, we could look at, okay, each document is associated, combining all the words together, is associated with this sort of value. And as I'm going to run a couple of the summary statistics. Actually, let's look at the histogram itself on the right. As you can see here, that the vast majority of the documents that are covering George Floyd's death are using this dictionary, highly, highly negative. Now, what that actually means is up to you as a researcher to interpret. Okay. So I'm gonna, unfortunately, we're running a little bit out of time. I won't take too long, but we're gonna quickly go through some of the other unsupervised models, such as named entity recognition and topic modeling. So named entity recognition. So let's say we want to identify specific parts of speech or specific organizations or people in the data set itself. If we look at Floyd.
Just real quick before we jump into all this, Todd,
Yeah.
Did anybody have any questions about the logic of sentiment analysis? Because we were just going through this and it looks like we're just shifting gears.
Yeah.
Just a quick question. Can it be done with like fuzzy kind of words, I guess? I mean, you had past tense and, well, anyway, is there a way to do it where you can take that into account?
Yeah, there definitely is. I think you're right with fuzzy sentiment analysis, which I think the traditional way to do it is through stemming, which means that words like police, like policed or policing, are stemmed and stemmed into like a word like police, which kind of reduces the data, but also collapses. It takes away a lot of the past tense, a lot of the gerunds, and a lot of that into, so that we could actually search some of these terms. You know, I'm blanking here, so Scott, you want to provide a better explanation? Feel free to chime in. But to answer that question, yeah.
Yeah, no. So here's a paper that Laura Nelson published like a month or two ago that talks about stemming and dealing with word embeddings in some detail. So that might be kind of helpful. There's kind of two ways to deal with it. Some deal with the stemming algorithms that search for root words and then try to expand out of it. And the kind of more old school way that typically gets done with the more dictionary-based approaches like we have here is to try to account for every single variation of a word. So one of the reasons the Bing lexicon is still widely used is because the authors created it in like 2005 and have just been adding words and variations of words and misspellings of words to it ever since. So even though it's really rudimentary, it's also quite comprehensive. And so one way to do it is to kind of take the algorithmic approach to get word embeddings and then do like a tree out of that in the stemming style, or the other kind of more rudimentary basic approach is to attempt to account for every variation of the word and build it into a dictionary.
Any other questions before we move on? Oh. Let's see.
Has anyone developed, like, I mean, this would be really hard to do, but like a potentially more like advanced like method that tries to take in like the context of the words immediately around a certain word? If you have a word that can potentially have opposite connotations depending on context, it'd be very hard to do. But like say you just like took this method and then you saw like the pattern of negativity, positivity, or like emotions around a word, and then tried to create like a more informed.
Yeah, so Todd, I don't mean to cut you off if you wanted to field this question. I can ramble though. It's a skill I've developed over the years. But so there's a lot of approaches to dealing with context, and they're all very, they get complicated very quickly, as you might imagine. So some of them deal with shifter words, where if you say not bad, it's gonna account for that shift and reverse the style of sentiment or reverse the score. So that's one kind of common rudimentary approach. Another one that's slightly more sophisticated was kind of developed by Chris Bale, and he published a paper in PNAS on it, which is the text-to-net approach, where you regard words as bipartite networks embedded in sentence structures, and then based on that, you can get a sense of context. I don't think that one's widely applied, and I think I think that needs some development. But if you were to talk to a computer scientist about the best way to deal with context, they would start talking about deep learning and neural networks. And that's kind of where the development is coming from there, because you can write, it's essentially developing a very advanced type of supervised machine learning algorithm. A lot of the ones that are popularly used are very rudimentary, but the neural networks and deep learning algorithms create various stages of learning that update the functions kind of underlying the algorithm to build in context in different ways. So there's various degrees of complexity for dealing with it. If you're simply interested in like handling sarcasm or shifter words, then it's a lot simpler. But if you're trying to build in like, you know, what is the themes in a book, then it takes a lot more work. And so it can get very complicated quickly.
Yeah, no, thank you. Yeah, I was thinking especially sarcasm if we're dealing with the internet. So.
Yeah. Cool. So I'm going to quickly go through just to showcase these tools, and then we'll cut it off and ask for questions. So named entity recognition. So I'm going to run this and then I'll explain what's going on here. So let's say we want to identify specific characters in the data, such as persons or organizations, or if you want to look at grammar structures as well, like adjectives, adverbs, how are people describing things. What a named entity recognition algorithm will do is it literally will, again, looking at each word and also looking at, I think, the context of each word as well, provide a categorization onto these data. So I've ran the actual code that you need. Let's actually take a look at the structure on Floyd_ENT and what this actually looks like. It's might tough to see, but you can see that like we have in the first document specific words like verbs, like wish is a verb, mu would be a verb. Again, you could think of this as like looking at specific words and applying some sort of categorization, like a punctuation, or for instance, Nina Simone is categorized as a person in this. And we could go a little bit step further by just looking at organizations, people. I think this NORP categorization, or this NORP entity, they call it an entity, or these Spacey R calls this entities. I think it's like nationalities and religious and political affiliations. Let's kind of just filter out words that only have that have entities of organization, person, or NORPs associated with them. And then for each, let's just, okay, cool. And so we could identify, you know, this is just in one document, we can identify, okay, Greg Abbott is a person, George Floyd, person, Abbott, person, Floyd, person, Derek Chauvin, person, Texan American Texans. We see specific organizations like FBI, Texas National Guard. We see some errors as well. So you can immediately see how useful this might be if you just want to identify, you know, media what organizations and what people are media citing. So this might be one useful approach. But as you can see here, that there's a lot of data cleaning to be done, particularly with some of these false positives, that this is definitely not a person. So that's like one useful algorithm that, you know, some of you might look towards if you want to look at various entities within text data. All right. The other is structural topic modeling, which overall is generally a tool that's used to summarize words, words in a variety of documents into different topics. Like you specify a number of topics. Let's say there are 20. You give a prior of 20 topics that all these words and all these documents are a part of. And based on word co-occurrence, it identifies what topics are prevalent in some texts. It identifies which words are more likely to be associated in which topics, and which documents are more likely to be associated in which topics as well. So it's a data discovery tool in a sense. And some of the results that we might get might be useful for us. And so I'm not going to run the actual code itself because it actually took me a little bit while to get through it. So in the model BLM Fit 20, let's see, in a model BLM Fit 20, I've specified 20 topics that all these articles could be, all these words and all these documents could be a part of. And I'll conduct just 3 different ways to look at these these collections of words. For instance, we could use this function label topics, to identify specific words associated with each topic. Topic 19 seems to be about athletics and maybe athletic activism, whereas topic 20 seems to be about various protests themselves. And then you could go further by using this find thoughts function to just verify, to validate, okay, we know that these words are associated with this topic. What's actually going on in the actual text data? And you would use this to figure this out. In that, I've noticed that one interesting thing that I've noticed is that topic 15, which seems to be about racism, like Black American people racism, seems to be associated with a lot of opinion pieces of organizations that are coming out with some sort of statement, like Northwestern University issued a statement. The Healthy Homes Initiative issued a statement, which is kind of interesting in of itself. So it's, again, you're discovering new insights with topic modeling. And I think this function itself makes, I think I would highlight this function itself as well, in that we could then actually calculate, it's actually, one final point before we end it. We can then actually calculate, I'm just going to open this up right here. We can actually create a data set of the prevalence of each topic associated with each document itself. So all of these from topic 1 to topic 20 add up to 1. So this is like the percentage of words. So each row represents a percentage of words in this document, in this article, that are associated with this specific topic. And from there, you could kind of do further analysis later on down the line. Cool. So I know that was a lot and it might be overwhelming to you, but I hope this lecture or this workshop just demonstrates some useful tools, but also challenges that you could use going forward with text analysis in dictionary-based approaches and unsupervised models. All right, so I know that was a lot, but hopefully some of you all learned something. Yeah, cool. So I think we can open the door for questions.
So would you be able, could you talk briefly about the actual data collection part?
Yeah.
I feel like from my experience, that is like the first and oftentimes the most hardest or second most hardest part of like doing data analysis. And I think web scraping is such a broad array of techniques. It helps kind of clarify what ways you could go about that, because in an ideal world, you don't have to grab the data is just there and then you just use it, but you have to not only get the data, you have to get the data in a good way that doesn't give you bad data. And
Mhm.
I feel like half of all of the complaints about data bias and whatnot is because the data was poorly collected or incorrectly collected. So, yeah.
Yeah, I think it's very important, and that's honestly what you should think through as a sociologist. I guess for this specific data, um, I I basically searched ProQuest newspapers, which has like a list of like 1,000 uh, media sources from 1980 to the present, and I literally searched, does this article mention George Floyd after his death? Does it also mention police and the city in which he was killed in order to get at, I did this because I wanted to make sure I'm capturing cases of people being killed by police, not uh, not another figure who happened to be mentioned, who happened to have the same name as someone killed by police. So I think this is definitely not exhaustive of all newspaper articles. And I think that's, that's definitely a good question. I hope, does that answer that question for you?
A little bit. Would
Yeah.
you also be willing to briefly, in like, I guess 2 or 3 sentences, describe, for our, I guess, like the coding techniques? Because it's a bit more complicated than using a library and then the library method calls if you're web scraping ProQuest specifically.
Yeah, I created a Selenium I created Selenium web scraper to literally go to this web page, search these terms, and collect data page by page of the results that I got. So cool. So I know it's 4, and if anyone happens to hop off, uh, that's all right. I understand people's time. I'll respect people's time. But if you want to stay on and ask more questions, I'm happy to do so as well.
I have
Yeah,
a
so-
question. Oh, sorry.
Sorry, Grace. I was expecting some people to be jumping to hop off, and maybe everybody's really excited to hang around. I was just going to say, our next meeting, we're going to have Lisa presenting a brief research idea on natural language processing, actually. And for people who don't know, Lisa is a graduate student, a PhD student in computer science, and she really wants a sociologist's perspective on how to account for social context. So I think that'll be a very interesting discussion. And Will is scheduled to also give a research brief as well, but so
We'll follow
have
up with them on that. Yeah.
But Grace, go ahead.
Yeah, so I'm kind of at the phase where I'm looking for like any kind of examples in the literature for stuff like this and just trying to like eat that up. And I was wondering if anyone had like any, especially you, Todd, like literature examples that you really liked and relied on kind of while learning this process, especially like theoretically.
Mhm. There's a lot of them.
Okay.
I'll spend some time thinking through, and I think I'll share them to the entire group.
That would be
in
awesome.
general, as
Yeah.
a follow-up. So we'll do.
Yeah, just like what you can think of. Sorry, I know that's a big ask. Sorry.
No, I understand that. I was at your stage a couple of years ago.
Oh,
Cool.
actually, Grace's remark kind of made me think of what I think would be a good question. So, Todd, you mentioned using Selenium to automate going into ProQuest and then searching out those specific articles. What do you think are like the broad outlines of what in computational sociology are typical methods and approaches for gathering the corpuses for the text mining? Because I feel like I've also seen a lot of like social media oriented text mining in the wild, which is a lot different than what Selenium would be used for, because at that point you create like a developer account on, say, Twitter, and then you just grab like tinier pieces. It's not news articles, but I don't know.
Yeah. No, yeah, you're right. There are a lot of different ways. I mean, text
No,
data can be.
what are they? That's my question, Todd. What are they?
Oh, that is a lot. I'm sure I guess just generally how people get text data. I think in social media specifically, you're right. Like, I think Will did a segment workshop on like how to gather Twitter data and the nuances on that. Other people I've looked at, they collected data from internet forums, not Facebook, but like forums of like, you know, specific organizations. Let's see. I mean,
I'll hop in here, Todd. I think so. A lot of it's, you know, it depends on the place. Like a big way, one of the projects I'm working with Will on right now is using sales reviews from darknet drug markets. One of the reasons Twitter gets widely used is because the API is really accessible, right? But other people have looked at things like Facebook posts. A really common tradition in research on media coverage is just to go through places like LexisNexis and download news articles, or go through Newsbank and download news articles. Some research even looks at like sentiment and key themes in books, right? And so there's a package you can download called Jane Austen, and it has all Jane Austen novels that you can play around with for sentiment analysis, right? And then there's other innovations too. So Laura Nelson, I think right now is probably the sociologist who's doing the most active work in text analysis. And she presented earlier this semester to Culture and Politics on an archival sample of a newspaper she had from 1930 that she physically scanned, did ocular image extraction, converted the text data, and then started algorithmic processing. So I think part of the reason Todd's having trouble getting to the core of your question is because there's a ton of different sources, right? And so a lot of it varies on kind of what you're interested in. I think the social media data tends to be the most widely used because it's the most widely available. But I think there's also a really strong research tradition in sociology of analyzing media frames and news articles. So I think that's probably the second most common type of data source.
Gotcha.
Any final thoughts or questions? Okay, so again, we'll be meeting April 30th, right? Yep, April 30th. And I think you'll send out an email, and that will be our last meeting of the semester. So folks, start brainstorming if there's any skills-based workshops you want us to offer in the fall, or if